Hello, we're going to continue with comparison between organic and inorganic compound. From this, I'm sure that you have passed through the different parts that I have taught you during the last sessions that support the special properties of carbons, and for today we're going to continue with this comparison between organic and inorganic compound. For those students who want to know this part of organic compound properties, must have an idea from different parts like inorganic compound. It means that when you try to compare this compound, you can determine that this is the organic or this is the non-organic compound. It means is the inorganic compound. So from that, we're going to differentiate this by starting with this first difference, that is carbon. In part of organic compound, say that carbon is the principal element together with the hydrogen, halogens, oxygen, phosphorus, sulfur, and a few metals such as lead. It means that this is due to the formation of the covalent bond. It means that most of the elements that is considered is about those that is non-metallic, but the principal element is carbon, but other like sulfur and the other fourth, it can be attached with this carbon to form different compound. Also the lead is sometimes it have ability of forming a covalent bond. And also in part of while the part of inorganic compound is that are composed of any of the known element. Why we say like that? Since we can see that there is a sodium, maybe hydrocarbonate. This one we say that it is inorganic. Maybe there is a sodium carbonate. We see here we say that there is a oxygen in part of organic. There is also carbon itself. So from that we can determine that this inorganic compound, it can compose both maybe organic or non-inorganic elements. But in part of the conclusion, we can make that there is a metal and non-metallic, metal and non-metallic. So this metal and non-metallic, it makes it to differentiate the organic compound and the inorganic compound. Since in the part of this one, organic compound, we can look that maybe there is methane. You see? There is this methane. It means there is carbon and for hydrogen. So from that, it seems these are non-metallic elements. But those in part of this inorganic, there is either metal and non-metallic at the same time. So from that now, we're going to back to the second difference. That is, most of the compounds are covalent in nature, as I said previously, due to the most of the elements that form organic compound are non-metallic, since the formation of the bond between those elements that are attached to form a compound is formed by covalent, by sharing electrons. It is based on sharing electrons. But in this, we said that most of the compounds are ionic in nature. Why it is ionic in nature? Because it is formed by ionizations. It means that the compound is formed by metal, maybe sodium chloride. It means that this is the positively charged and this is the negatively charged. So we say that by ionic. So it means that there is a cationic and anionic charges that maybe lose or gain. So it means that this one is lose and this one is gain to form compound. So the difference is that. So again now we go to the third point, that is have low melting point and the boiling point. We say it's the low melting point and the boiling point due to the covalent bonded together. It means that the bond that formed the covalent always is weak compared to that formed between metal and non-metal. Since here the one which formed between metal and non-metal is small in size in almost. So from that the different electronegativity that exists between itself, it seems to be difficult to be break down. So the melting and the boiling point to be high in order to break it, to make it free and ions. You see? So now we go to the fourth one, that is, there are many classes based on the fraction group. Here the classes that we can look about, maybe it may be hydroxyl, it may be carboxylic acid, it may be ketone, it may be aldehyde, and several fourths. So there is amide, there is amine, and others. So from that we can look that here there are many classes depend on what, on the fraction group. But here in part of inorganic compound, we base it in a few classes, maybe salt, maybe acid, maybe what, bases. So salt, acid, and bases are the major constituents, or are the major existence of classes of inorganic compound. So from that now we're going to back to the fifth ones, that we said that they are most insoluble in water but soluble in organic solvents such as, so it means that this one, the thing that I will say insoluble, when you say insoluble, it means that it is difficult to be mixed with. But when we say soluble, it means that I have ability to mix the with total. You can see it is mixed the total. You can't differentiate that there is a certain things and there are certain things from that solution. So it means that when we say organic compound are covalently bonded together. It is not ionic. So here is obey the principle that said that like dissolve like. So it means that the organic compound, it must dissolve in the solvent that is the organic compound, like benzene, cyclohexane, alcohol, and ether. But for inorganic compound, it can dissolve in water. Water is the major solvent for inorganic compound. But for organic compound, there are a few or some of organic compound that can dissolve in water, but in rare, but commonly is soluble in organic compound. You see. Now we're going to back on the two from rust, that is, they are poor conductor of heat and electricity. We say that a poor conductor of electricity since it's covalently bonded. Also, it can't make a free electrons since it is covalently bonded by sharing electrons, but not by losing and gaining electrons. But this one is by sharing electrons, and also it is insoluble in water. So this one, it can be the major part of this property, that they are poor conductor of heat and electricity since they have the ability of making free electrons. But this one is the good conductor. Why? Because it's found between metal and non-metal that make free electrons. Like I said previously, there is sodium ions and chlorine ions. So this one, it make it to be free, that can support to conduct an electricity. But this one most is formed by non-metallic, which is sharing electrons and making electrons to be free from its orbit. So it seems to be difficult to conduct an electricity, but for some is rare. And the last point is about the reaction of organic compound generally produced slowly. It means that the reaction of organic compound generally is produced slowly compared with this one. The reaction of an organic compound generally proceeds fast. We say it proceeds fast. Why? Due to the nature of the bond that is exists. But this one, it needs a certain condition in order to be in a certain reaction, and that reaction is seen to be slowly. Why? In a part of organic compound, since the bond that exists always is strongly, but not such only in organic compound. And also the second reason is covalently bonded together, that the electrons it does not free to be in the reactions compared with this side. So here it seems that the reaction is faster than in part of organic compound. But in part of organic compound, we can say that the reaction is fast depending on the nature of the reactions in which condition is taking place, but in rare, but not in common as in organic compound. So from that, we can look much about the other thing that is about isomerism. We can look about isomerism. Isomerism, this says that is the existence of compound of the same molecular formula but different structure formula. Or arrangement. So the situation of a compound to be of the same molecular formula, but in a part of arrangement of the constituent of the fraction couple, the bonds to be in a variant arrangement, but the formula seems to be the same. This is what we call isomerism. But compound itself, it means that isomerism is the existence or is the situation that make by the certain compound to be in such a way. But when we say isomers are compound itself that have the same molecular formula but different in the structural arrangement of the compound. So there's a difference between isomer and the isomerism. Isomerism, it is the existence, but the isomer is the compound itself that have that property of having the same molecular formula but different in the structure arrangement. So from that now we can look about the types of isomerism. Types of isomerism. Types of isomerism, there are two types of isomerism. The first type is constitution or structural isomerism, and the second is stereoisomerism. So from that of today, we're going to end with this type of isomerism, that is constitutional isomerism and stereoisomerism. And I know that for the another session, so we'll continue with these types by discussing more. I'd like to say thank you. Welcome to the another session.